Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter waves. Okay, so let's start the video. Question is, a sinusoidal wave of wavelength 7.5 centimeter travels a distance of 1.2 centimeter along the x direction in 0.3 second. The crest P is at x equal to 0 at t equal to 0 second. Okay, and maximum displacement of the wave is given here 2 centimeter. Now, which equation correctly represent this wave? So after reading this question, you can understand very well the wave is traveling along the x direction. Okay, so based upon that, we have to just think about a wave that is traveling along the positive x direction by default. Okay, so for the positive x direction, remember that here under the sine function, it can be kx minus omega t or omega t minus kx. But seeing the option, we can see very well we have to write in the form of kx minus omega t. Okay, so equation can be like this. So y equal to a sine kx minus omega t, or we can write here a cos kx minus omega t. Both represents a PPHW wave, that means plane progressive harmonic wave. Okay, in this medium particles will perform oscillatory motion with respect to mean position. Okay, and this wave anyhow traveling along which direction? Positive x direction. For positive x direction, you can write omega t minus kx also, not a problem. Okay, so after that we will get one by one. Now what is A? A is the amplitude, that means maximum displacement from the mean position. So you can see very well the maximum displacement of the wave, it is given here A equal to 2 centimeter is there. Okay, after that next one, this k. Now if I talk about this k is called angular wave number. This angular wave number is given by k equal to 2 pi by lambda. Okay, so 2 pi value we can tell 3.14, and the lambda value. Lambda value in the question you can see very well. This is the lambda value. It is given here 7.5 centimeters. So we can write here, see, 7.5 into 10 to the power minus 2. We have to convert. Okay, so when you will simplify this expression will come nearly 0.83 meter inverse. Okay, this is the angular wave number. Okay, next one, what we have to calculate? We have to get the omega. For omega, there is the one formula is there, V equal to omega by k. Okay, so k we know, so if we can get the velocity, we can get very well. Okay, so to get the velocity of the wave, anyhow, this is not the electromagnetic wave. Is it? Electromagnetic wave travels with the speed of light in a vacuum, but here this is a mechanical wave. So to get the speed, what they're telling that here, see here, 1.2 centimeter along x direction in 0.3 seconds. So speed means we can see here distance by time here. So distance what is given here, you can see very well here 1.2 centimeter, and time how much is there? 0.3. so 1.2 by 0.3, it will come here 4 centimeter per second. This is the speed of the wave. Okay, next one, remember that here we know V equal to omega by k. So from here, if I'll get here the omega is called V into k. So what is the value of the k? You know very well, 0.83. This is the value of the k into meter inverse. So this thing we have to also convert into meter. So we can write here 4 into 10 to the power minus 2. Is it? So 4 into 10 power minus 2 means 0.04. So when you will simplify this very easily, this will come here 3.35. Okay, 3.35, and we can tell here radian per second. Okay, so we have got all these values and all that, and then we have to just put here in this equation. Okay, so you can see the value of k is 0.83, here also 0.83, here also 0.83, and the value of omega, this omega, you can see the value of omega will be 3.35. so where is the 3.35? You can see here, is it? So you can see very well the expression is going to be the cos here. Okay, so from here, if I just write from here, remember that here this y will come here 2 cos, and k value what is given here 0.83 minus omega what is there 3.35. so we can write here 3.35 into t, and unit will be anyhow centimeter. Okay, so which option is correct here? The correct option is here option A is the answer. Is it? And this is plane progressive harmonic wave. So students, I hope so. This video is very clear to you. Keep studying, keep going.